And then we have part C. Oh, they tell you it's purple. I'm not sure why we need to know that for the question, but it is purple and it is acidified. What tends to happen when you want to acidify this is you just add some hydrochloric acid into the solution. So this is potassium permanganate solution, which means KMnO4AQ, because it is a solution, is decolorized. So when the redox reaction happens, it will go from purple to colorless, and it is decolorized by acidifying iron to sulfate. So kudos to anyone who could write this properly without consulting anything. Good for you. Mn2 plus is going to be produced, and Fe3 plus is going to be produced. Okay. You know, I'm going to change things up a little bit. No, actually, no, I'm not doing any of that. I'm just going to find oxidation number first because, you know, it's a good place to start, always, at the very beginning. So there is an increase in oxidation number of iron from positive 2 to positive 3, so that's your reducing agent. Your oxidizing agent is going to be manganese, which goes from positive 7 to positive 2, so this is your oxidizing agent. Okay, before I start writing anything, I'm going to check to see whether I could split the molecules or the compounds. This is an ionic compound that is aqueous, so I could write it as K plus and MnO4 minus, and the permanganate is going to be what actually undergoes reduction, so you could ignore K plus being a spectator ions. Similarly, for iron sulfate, you can write it as Fe2 plus and SO4 2 minus, and the sulfate is also a spectator ion. So for reduction, really all you have is the same half equation that you probably have written at least 3 times in the past. Well, I've written at least 3 times in the past 2 days. So MnO4 minus going to Mn2 plus with 4 H2O and 8 H plus and 5 electrons. You will once again write this so many times this year that you effectively would memorize it. For oxidation, we're going to have Fe2 plus going to Fe3 plus. So we're going to add 1 electron to balance it. Before I add them together, I do need to multiply the oxidation by 5 so that the number of electrons is the same. And the overall is going to be MnO4 minus plus HH plus and 5 Fe2 plus going to Mn2 plus 4 H2O and 5 Fe3 plus. Let's do a quick charge check. -1, +10, that's +9 overall. That's weird. Oh no, there's 8 of these as well. +9 and +8 is +17, and then +2 and +15 is +17. Good stuff. That's part C.